Hey, what's up guys, my name is the Cherno. Welcome to a classic Hazel devlog. So today I wanted to talk about two major new features in Hazel that we actually shipped as part of our latest game. For those of you who don't know, we made a game called Dichotomy. I'll have a link to a video up there if you want to check out more details, and there'll also be a link below to play it. Just a little game we made in 72 hours for a game jam. And I'm sorry it's been such a long time between devlogs. Honestly, I've just been full steam ahead working on Hazel or other videos, and I've had barely any time to kind of document the journey. It's a little bit unfortunate because I would have loved to have made more devlogs, but maybe we can do more of these chill ones, and that way I can find the time. I think a big problem for me is I just want to make them better produced, and that stops me from making anything at all. And I'm still kind of fighting that. Okay, so before we get into the two major pieces of technology, I just want to thank all of the wonderful Patreon supporters who have made Hazel possible. I actually released a very long post on Patreon talking about the journey up until this point in time, and also what happens with the money and how that actually funds Hazel. If you want to support Hazel's development and get access to it, then patreon.com/thecherno is the place to go. Okay, so what are these two features, and why am I calling them such major features? So last time we actually released something in Hazel was all the way back in April. It was a game called Forest, which we made also in 72 hours for Ludum Dare, a game jam. That was kind of a major milestone in and of itself, and even though the game wasn't particularly good, it was more of a tech test of what can we make, it still represented the first time that we were able to actually ship a product with Hazel, which up until then was something we never did before. Well, we actually made a game the day before that game jam started and quickly released it just to make sure we could release something, and that game was called Fragile, but we won't talk about that. However, even though we were able to physically ship a product, it was far from what I would consider the proper way to distribute games in general. I mean, if we just take a look at what Forest looked like when you downloaded it. So we had a launcher, that was pretty cool. We could set our settings, we could hit play. But if you actually go into the directory, this kind of directory here is pretty much all of the raw assets and project files. So imagine that you've made a game in Unity, but instead of building it into a package and shipping it as an executable, you kind of just ship the Unity project. That's basically what we did at that point in time. If we look at this a little bit more closely, we can see we have things like Asimp here, which is a 3D model importer, which is not generally something you would need in a runtime of a game engine, because you should be using your own 3D model format. You shouldn't be using FBX or GLTF, because those are intermediate formats. But then if we go into data, we have this assets folder, and inside the assets folder, well, guess what? This is all of the raw assets. If we go into audio and source, we have a bunch of OGG files here. If we go into meshes or models, we have all of these GLTF files that we can just simply open. And here we have this chest or whatever. All of these files are just here. And then inside scripts and binaries, we also have the main kind of C# DLL. This isn't too much of a big deal. This is how Unity used to ship their games as well, before the whole IL2 CPP thing. But in general, you can see how, all of the scenes, for example, village.hscene, if we just open that up in Visual Studio Code, you'll see that, it's all here. You could edit, all of this, because it's all kind of the raw assets. This is, physically the scene file in YAML, as Hazelnut, the Hazel editor, would actually open it. So whilst it's obviously possible to ship a game like that, it's very far from ideal. There's two major reasons. First of all, asset protection. You generally don't want to give people the opportunity to easily just steal your assets and do whatever they want with them. I mean, you could literally rip all the assets and just publish them on a 3D model website. I guess you could argue that it makes modding really easy. If I wanted to replace the gun model with something else, it's as simple as just replacing that GLTF file and you're kind of done. So yeah, whilst full modding support out of the box might be considered a positive feature in a lot of regards, overall, it's probably not that great to just give people access to all of that. The other major issue with this, though, is performance. So for example, let's take 3D meshes. 3D meshes have some kind of model file, and then they usually have associated materials and textures specifically, so image files. The two most common 3D model formats that we kind of find today are FBX and GLTF. There are certain other ones, but they're less popular. Both GLTF and FBX are known as intermediate 3D mesh formats. The reason they're called intermediate formats is because generally you work with those formats when you're actually authoring assets. Every single game engine, like Unity, Unreal, Frostbite, whatever else, they will take that intermediate format and they'll usually accept a whole range of them, and they will convert it into an engine-specific format. Because there is basically no way that intermediate format is going to be optimal for the engine. Now, of course, you could do this at runtime. You could ship a game with an FBX file or a GLTF file, and then you could just read it and like process it and transform the data, I guess, using some kind of importer like Asimp. You could roll your own, whatever. But the fact is, all of this processing that you're doing doesn't really need to be done. Because what's the point of opening a file, reading the parts that you need, and then changing them into some other data structure or layout? So for example, it might be extracting all of the vertex positions, all of the vertex normals, everything you need, loading up buffers, and then sending that to your GPU as like a vertex buffer. Why would you do that every single time you launch your game? Clearly you're trying to get to the same end result every time. So why don't you just do that processing ahead of time? And that way, if you ship your game with those assets already processed, then it is literally as simple as just read the data from disk and into CPU memory, or read the vertex buffer data from disk into GPU memory. Like that's all you need to do, because it's already perfect. It's already in the format you want it to be. So those are kind of the two reasons why you might want your own 3D model format. It's the same kind of situation with textures. For textures, we typically store like the master assets as like a PNG or a JPEG maybe. Both of those are compressed formats. PNG technically doesn't have to be compressed, but it usually is, which means that every time we read it, we have to decode it. We have to go through and process all those pixels, decode the data, and then we might actually need to compress it into a different format, such as like a GPU texture compression format, and then send it to the GPU. That's so much extra work for literally no reason. There might be some further processing that needs to be done, such as custom filtering bitmaps for whatever reason. A great example of that might be for like environment maps. You don't want to just have your GPU linearly filter everything. You want to use a custom filtering sampling algorithm that will give you much nicer results. I know I'm kind of going down a rabbit hole here, so I'll probably just digress at this point and stop, but you get the point, hopefully. Asset protection and performance slash also I guess size of assets on disk. You might not use every portion of the model, so why would you want to ship everything? Those are kind of the two downsides from how we, I guess, shipped assets in Forest. And obviously I knew that this was something that needed to change. This was just like a first step to, let's just ship something. Okay, we can just ship it in this format. That will be easiest of all because we don't need to spend time creating our own formats and kind of packaging all of this. But now, if we take a look at dichotomy, so it looks very similar to just the raw kind of folder here. We have a launcher. We have obviously the graphic settings and everything. If we go into dichotomy itself though, and we take a look at it, we have this LD51 folder. That's just what it was called. We've still got an assets folder, but if we look in the assets folder, this is what we've got. We've got this thing called a sound bank. We've got an audio commands registry, and we've got an asset pack. And you might notice that the asset pack is actually kind of large. It's like 100 megabytes. Inside the levels directory, we have these PNG files, and each one of these PNG files is a level inside dichotomy. We specifically didn't package these into the asset pack because we wanted people to be able to make their own levels. And the way the game actually works is it reads this directory and it plays the levels in like alphabetical order. So in that sense, we kind of, I guess, shipped the game with modding support, you could say, out of the box, or at least your own level kind of creation support out of the box. It also means you can delete levels if they're giving you trouble, and then the game will simply skip them. So that's why the levels directory is here. But otherwise, you might notice there's no 3D models, there's nothing. There's just an asset pack. And that asset pack contains like literally all of the assets except for sounds. All of the audio assets are inside this sound bank. And there's also an audio commands registry. This will probably likely also be combined into the asset pack in the future, but because we have Jay working on audio and he kind of started the system before I started the whole asset pack system, it was just a lot easier for this game at least to just ship them as two separate systems like this. And this asset pack file, if we just open up like a hex editor, is just a bunch of binary data. You can see it has this header, HZAP, Hazel asset pack, and then it's just binary data. And it starts with like an index, and then it literally just has the binary data for like everything else. Now, if you guys are interested, I might make an in-depth video talking about like how this works on a technical level and all of the details. Drop a comment below if you'd like to see that. But otherwise, all of the assets are just inside this single file. You can build one of these from Hazelnut. Hazel's editor by just going File, Build Asset Pack, and it will automatically build this single file with all of the assets that are actually referenced by your scene. So if you have a bunch of assets that you don't even use, it's going to skip all of those. All of the assets that are actually used inside your scenes and inside your game, they will be packaged over here. And when you actually launch the games, if we just launch Dichotomy, you'll see over here in the bottom, like for the first, I think 8 seconds or so, it shows this, right? And then after a while, it goes away. If we open it again, here it is. And it says the version of the binary as well as the version of the asset pack. And they're separate because obviously like the asset pack is separate to that executable binary of the actual like game application. And you can kind of update them separately completely. And you might want to see what version of each you're on. If we just launch this again, you might notice that this number's pretty big. It's actually the date and time. So here we have like the year, the month, the day, and then the time in like 24-hour time, so like 4:07 p.m. And the reason it's like this is because this is very, very useful when you're actually shipping this, because you know exactly when you built this. So therefore, what version am I shipping? Like, what is this asset pack? When was it built? So I really like having this instead of just like some kind of arbitrary incrementing version like we do currently for the actual executable binary builds. Now, the other thing you might notice is that other kind of binary, the other DLL we had here, asimp, this is gone. We don't need it anymore because everything you see here, all of the 3D models, like these things, which are actually skeletal animations, that's entirely using Hazel's own model format. That has nothing to do with asimp. And it's already in that perfect like data layout where we can just read it from disk and we have everything we need. So for example, like the entire node hierarchy, all of the bones, all of the stuff we need to know for that, the submesh transforms, all of that can just be copied directly into like a CPU side struct. And then all the vertex buffers and index buffers are also just stored as is on disk. So we can just kind of stream them in basically directly to GPU memory. And that's it. And the performance gains of that are just huge. In fact, I might make a video talking about the performance of this specifically because I think it's just such a useful thing to do. And it seems obvious, but I don't know, maybe some of you haven't even thought of making your own 3D model format. So yeah, highly recommend. Now, the second major feature that we shipped with. What's that? What's the time? Wow, I've been recording for a long time. Huh. Guess you guys will just have to wait till the next devlog. Soz. Maybe download Hazel while you're waiting, and then you'll see.